Here I'm introducing a metaphor of wolves and goats to describe what happens in a redox reaction. Redox reaction always contains a chemical species that provides electrons. This species is said to undergo oxidation, right here. The other species takes electrons, undergoes reduction. So these two words together make up the portmanteau word redox. Reduction, oxidation. Now, wolf and goat metaphor. The wolf represents the chemical species that takes electrons. The goat is the species that provides electrons. So this is a way of thinking about it. The wolf is going to attack the goat and steal its electrons. In a redox reaction, the wolf attacks the goat and steals its electrons. In this process, the wolf's hunger diminishes, represented chemically by a decrease in its oxidation number. The wolf gets reduced. The goat gets oxidized. Here's an example. Suppose we had Ag+. That could gain electrons and turn into Ag neutral. That would make it a wolf. Gaining electrons is something a wolf does. And you can see the oxidation number decreases. Ag+ is an oxidation number of +1, whereas Ag neutral is oxidation number 0. +1 goes to 0. That's reduction. Ag+ is a wolf. Second part of this lesson is balancing a redox reaction. They can be very difficult. Wolf and goat metaphor can help. Here's the riddle. Suppose you have a wolf that needs 7 electrons to satisfy its hunger. If each goat can provide only 2 electrons, how many goats must a wolf kill to satisfy its hunger? No waste of electrons is allowed. So here's the cartoon. You can see there's a goat that provides 2 electrons right here. Here's a wolf saying, I'm pretty hungry. I need 7 electrons. You should see this is not possible to solve the riddle if we have only one wolf. But if you allow the wolves to hunt in packs, it is easy to satisfy the wolf's hunger without wasting any electrons. So here's a solution to this riddle. 2 wolves. Kill 7 goats. Exclamation point. Times 7 would be 14 electrons provided. Times 2 wolves would be 14 electrons gobbled up. That's the answer to the riddle. Here's how you apply the wolf and goat to balance an equation. So here's a complicated redox equation right here. These steps, A, B, C, D, E, F, will lead us to a solution to balancing using the wolf and goat metaphor. Which element is reduced? It'll be the chromium. You should see the chromium here is a +6. But on the other side, it's +3. So it's Cr is reduced. The second question is which element is oxidized? That element will have its oxidation number increase. Here's Fe in a 2+ state. On the other side, it's in a 3+ state. Fe, iron, is oxidized. Now we're on C. Each chromium changes from +6, we've seen that, to +3, meaning it needs 3 electrons. It's the difference between +6 to +3. 3 electrons satisfies its hunger. We can put that in the cartoon. Each goat changes from +2 to +3, meaning it provides a single electron. In the cartoon, I'm giving each goat an electron. In order to feed the wolf, this reaction will require 3 goats for every wolf. You can see it right here in the cartoon. 1, 2, 3 goats will feed the 1 wolf. This means that the coefficient for Fe+2 is 3. 3 of those. And the coefficient for the wolf is 1. 1 wolf, 3 goats. 1 wolf, 3 goats. So you can see that the numbers carry over from side to side. 3 iron atoms in the beginning mean 3 iron atoms in the end. So this 1-to-3 ratio, 1-to-3 ratio, 1-to-3 ratio is key to balancing the equation. The rest of the equation, you see there's only 2 spaces left for this H+, for the H2O. That's balanced using standard techniques. We just look at the atoms and count them. So oxygen, there are 4 oxygens right here. Right now there's only 1 oxygen in the end. So this coefficient needs to be a 4. That will provide 4 oxygens in the end to balance the 4 in the beginning. Last coefficient is the H+. What's the number there? 8 hydrogens in the end. Requires 8 hydrogens in the beginning. So you can see that this equation has now got some very large coefficients, but it is correctly balanced with 1, 3, 8, 1, 3, 4, and the wolf and goat helps get this very important ratio, the 3-to-1 ratio.